Okay, this is Tic-Tac-Toe from CS50's Intro to Artificial Intelligence Week 0. The purpose of this project is to create the AI for a tic-tac-toe game. And we got the tic-tac-toe game working here. So first I'll let the computer play as X and I'll play as O. And the computer will pick a random first move at first just to get the game moving, and the first move doesn't really matter. So if I'm O and I play something silly to throw the game, it's going to immediately find a way to win. And there I had a couple of different options. But if I'm playing a little bit smarter, and I'll play as X this time, the game is definitely going to end in a tie just about every time, and it will never let me beat it. So it's because tic-tac-toe is a solved game. There should be no situation where I'd be able to trick the computer or something like that. Put that away. Okay, so how we've done that is with a minimax function. And what a minimax function does is it takes a minimum value, and usually they would start from maybe negative infinity, and the maximum value would be infinity, depending on if you're the minimizing player or the maximizing player. But with tic-tac-toe, since it's either going to be O wins, X wins, or a tie for values of -1, 0, or 1, then I decided -2 and 2 was enough. Now, to determine the best play at every state, is going to look at all of the possible actions and create kind of a hypothetical board state for each of those actions. And then for that board state, it's going to take a look and see, well, what would the opposing player do in order to minimize his score, maximize the score, whatever the case may be, and then create another board state. And well, what would X do if O does that? What would O do if X does this? Until it reaches a terminal outcome for each state, and then it's going to pick the best move for either X or O, depending. And in order to optimize the search a little bit, I implemented the alpha-beta pruning, which only searches the outcomes of a particular board state until it finds that there is an outcome that the opposing player would pick that is worse for us than what we've already found. And if that's the case, we know we're not going to pick that state, so there's no need to search any further. It's a dead end. And that did actually speed up my results by quite a bit. I was surprised that that made the first couple of moves a lot faster to play, a little bit more snappy. So anyway, that's tic-tac-toe, and I'll see you next time.